Imagine a pair of twins like this. One of them takes off on a spacecraft traveling near the speed of light to embark on an interstellar journey, while the other stays on Earth. When the traveler returns to Earth, they find that their sibling has aged significantly. This is the famous twin paradox. So who is actually younger among the twins? First, our universe is made up of 3 spatial dimensions and 1 temporal dimension, forming 4-dimensional spacetime. We can move freely in any direction in space, without any restriction. But in time, all objects follow a straight line from the past to the future, and are compelled to move forward without ever turning back. According to relativity, the speed of an object's movement in 4-dimensional spacetime, the combined speed of movement in space and time, is considered a constant quantity. In other words, the faster an object moves, the slower time passes for it. When the spacecraft takes off, it and Earth move forward into the future together. But as the spacecraft approaches the speed of light, its trajectory in spacetime gradually diverges from that of Earth. The time axis of Earth and the spacecraft will no longer align. If we return to Earth at this point, we'll find that the clock on the spacecraft has been running much slower than the clock on Earth. Additionally, massive objects can warp spacetime, causing time to slow down around them. Suppose the spacecraft gets close to a black hole with an extremely strong gravitational pull. Due to the influence of the escape velocity near the black hole approaches the speed of light, causing the spacecraft's relative time to slow down. Thus, light emitted from here takes longer to escape the black hole. But for a distant observer, the light they receive will gradually slow down. They would see the spacecraft as if it were stationary. When the spacecraft leaves the gravitational field of the black hole, from Earth's perspective, it will take much longer to complete the journey. So, when the craft returns to Earth, it will feel as though it has traveled to the future. This is also why, during interstellar travel, an astronaut on a 2-year mission in space would be younger than their daughter upon returning. And even if we could exceed the speed of light, we still couldn't return to the past and meet our former selves, because that would merely mean chasing the light that left Earth a long time ago, and all you would be able to see is a rewinded view of Earth's past. You might even witness the scene of Emperor Qin Shi Huang ascending to the throne, but you wouldn't be able to alter anything, because as soon as you stop moving at the speed of light, the images you see would return to a normal, forward-flowing state. If you return to Earth faster than the speed of light, the scenes would accelerate forward even faster. Considering the universe and the effects of time dilation, by the time you return to Earth, it might have already been hundreds of years. This is also why in the timeline, the continuous sequence of light cones forces us to move only from the past to the future and compels us to move forward without turning back. Because even if we could theoretically travel into the future, we could never truly go back to the past.